Good afternoon again. That's the subject of the next hour. AJAX-based web applications. That's a very recent buzzword and a very big hype around it. And I'm going to talk about, or going to bash this buzzword a little bit and deflate the hype, but still explain why it's still great to have all that. For the title, Great Expectations is a book by Charles Dickens about poor people, right? And Greater Expectations is a talk about even poorer technologies. So that's to set the stage a bit. What we are going to talk about, again, is AJAX, what it is about, what it is not about, then again, what it really is about, why all what it is about is so bad, and why it's not so bad that it is all that bad. So, and I didn't mention this so far, but I'm working as a software engineer at Google, and my work is mostly concerned with Google Maps, and so I can make a few remarks as well what, for software engineering practice, also what these new technologies that we call AJAX. Is this microphone open too? Maybe we should close it. Then we don't have, yeah. So I'm going also to say a few words about engineering or software engineering practice and why AJAX-based web applications lend themselves or provide advantages also from the software engineering practice point of view. And I'm going to conclude as well, of course. Anyway, so AJAX is a new word that was coined in the beginning of this year, about in February or something, and it describes a new way, or a relatively new way, to build web applications. So, so first, let me expand this acronym. So it means asynchronous JavaScript and XML. So the thing is, all of these parts of the name are either non-essential, that is, you can do the same thing with something else, or they are redundant. So let me just briefly go through these components. First, asynchronous. So as you all know, web applications are mostly about user interaction. So the most important thing about a web application, and also as it turns out, one of the most complex things, is user interactions. So, and we all know how we build interactive applications that have a user interface. So they are mostly event-driven. That is, whatever happens, happens as a reaction to an event. And events are generated by the framework in which the application is written, and then handled by the application. And then an application that has a graphical user interface and is meant to be interactive is basically a bunch of event handlers. And events make the main flow of control in these applications, and events are handled asynchronously. So that is, if you want to build an interactive application, then you do it asynchronously as well. So there's no other way, basically, to build meaningfully interactive applications. So whatever we are doing in the web, it's asynchronous anyway. The second thing is JavaScript. And a main thing about AJAX or new types of web applications is to pull at least user interaction logic and in part also application logic from the server to the client. That is, while as previously pages that are displayed in the client were pretty dumb in HTML and didn't do much, now they are doing much. That is, we are writing up application logic and putting them in the HTML page that is sent to the client and runs in the browser. So in order to do that, we need a programming language, of course. And JavaScript is the programming language that we are happening to use, but the thing is, there are not much alternatives, actually. So there used to be Visual Basic Script around, in Internet Explorer, at least, but that is not really, I mean, nobody really does it. Microsoft, of course, has also an other scripting language implementation called JScript, which turns out just to be JavaScript. So that is JavaScript already. And there are other scripting or environments that provide interaction around, such as Flash, for instance. However, Flash also contains a scripting language to implement user interaction logic, and that scripting language is also JavaScript. So there's really not much choice for scripting languages in the client-side environment, runtime environment of web applications. So there's no other choice for JavaScript, actually. So the last thing, XML. As we will see, this whole thing about putting user interaction logic in the page or in a web page has a second component to it. That means that the page is not only very smart and does very many things in reaction to what the user does to it, without reloading itself all the time as it used to be in older web applications, but it also has to talk back to the server occasionally. However, AJAX web applications don't do it like older web applications by reloading a whole page, but they talk to the server in the background, fetch data in the background, and if the data arrive, then those data are used to update or augment the page. So, and in order to transfer data, you have to format data. So you have to transfer these data in a data format. So now, since 10 years or something, or maybe 15 years, whenever there is talk of transferring structured data in the internet, it somehow has to be XML. So the data transfer format for structured data has to be XML, and also in this case. Although, actually, it turns out that, first of all, it doesn't matter what structured data format you are going to use if you are doing this, because other properties of this architecture are much more important than this particular aspect of formatting structured data in XML. And it turns out that there's actually a much more canonical structured data format that lends itself much more naturally to be used in these AJAX-type web applications, namely JavaScript object literals. So, and I'm going to talk about those in a little bit more detail later. That doesn't mean that XML is bad altogether. It just means that it is quite arbitrary what you are using as the data transfer format. So basically, all I'm going to talk about is how to do client-side scripting in web pages, only right. So, and for some weird reason, I mean, if you think about how you script a web application, then you think deeply about it, then you just get to something that is AJAX today. But it is actually possible to do this since 10 years or something, and widely done since 5 years. And only nowadays it has been widely noticed that it is possible to build such applications. So now, however, as we have seen in the design patterns revolution, also in the mid of the 90s, it is very useful to have a name for things that we are talking a lot about. And since these new types of web applications are being talked a lot about recently, it is still better to have a bad name or a name that is inflated by hype than to have no name at all. So, and that's why I'm going to use this AJAX name occasionally, although I'm demonstratedly not very fond of it. Okay, so what happens in web applications? So just to set the stage again, in classic web applications, there are only two types of interaction with a web application that are exposed to the client. You can click on a link or you can submit a form. That's basically all you can do, and all types of interaction that a web browser that displays HTML supports. So, and as a reaction to this user interaction, that is as a action that is mapped to one of these two user events that are the only possible in HTML-based web applications, an HTTP request is created, sent to the server, and the server comes back with a response to it, which is usually an HTML page that replaces the HTML page that was displayed before. So that is for everything that you do to a web application, the whole display or the whole visual front end of this web application vanishes and is going to be replaced by something very similar to the previous one, but physically entirely different. So, and the thing is, on the client side, there's a generic event action mapping. So there are only two events, and there are two predefined actions that happens to these events. So, and these two actions actually are mostly the same. They are an HTTP request. However, what we are doing now in these AJAX called modern web applications, we can put more sophisticated event handling logic in the page. That is, we can write up event handlers that are put into the page and sent to the client and run actually as programs on the client side in the web browser. So, and they can do much more sophisticated things and much more application-specific things without talking back to the server. So what happens is basically we have a much larger set of user events, and we have a much more sophisticated way to define actions that happen on these user events. And these event handlers usually just update the page without replacing it and without talking back to the server or something. So they just can modify whatever is displayed in the browser and replace it, change it, whatever. And they also can talk back to the server. That is, they can send a request to the server in the background and wait, or don't have to wait, but will be notified by another event that the response is there. And as a reaction to this response, they can incorporate the received data from the server in the page without replacing the page, but just by updating the page. So that's what happens in AJAX applications. So this has two important consequences. So the first thing is, as I described, not the whole page vanishes and is replaced by a page that is quite similar to the previous page for every single tiny bit of user interaction. So that is, we can actually build visually appealing or smooth web applications, or web applications with a user interface that looks like user interfaces for graphical applications looked 20 years ago before the web was invented. And we can also make quite complex user interactions. So we don't have, in the early web, we could only click on buttons, click on links, that was all. And now something like a drag and drop becomes possible, or dragging becomes possible, or some complex things like tree widgets. Something like that is now much easier possible than it used to be. The second big thing doesn't concern the user interface, but rather web application architecture. And that's a client-side session state, or session state at all. So if you look at it, the original specification of the HTTP protocol stipulated that the HTTP protocol is stateless. And that basically, whenever you make a request to the server, to an HTTP server, and a response comes back, the request is entirely sufficient to specify the response. That is, the server doesn't have to know or doesn't have to remember that there are clients out there that talk to them in a sequence of requests or whatever. But if a client sends a request to the server, all the server has to do and has to remember is, or has to do is to respond to this request. And it doesn't have to remember anything, basically, except for what is stored on the server in forms of files or documents anyway. So, and with the advent of more complex interactions, like logged in or personalized user interfaces, or personalized web pages, or longer dialogues that span multiple pages or so, lazy software developers came up with the idea of server-side session state. That is, they recognized that usually a client is not making one request at a time to one server and then never again, but usually one client makes a sequence of requests to the server. So, and these sequence of requests actually establish a state. So for instance, I fill out a form partially or so. First the first section, then the second section, then the third section, and so on. So, and this basically establishes a session state of this user interaction. So, and the lazy thing to do was to manage this session state on the server side. That basically a client out there is associated with a session object that is maintained by the server, and the session object is just remembered by the server. And whenever a request from the same client comes in, it can, or it is evaluated and responded to in the context of the server-side session. So this, of course, creates all kinds of hassles. So most of them, or it starts again with the technical hassle. So for instance, if you scale up your server infrastructure, and instead of having one host that hosts your server, have say 100 or 1,000 hosts that host your servers, you have to make sure that the request gets all the time to the same host, because that's the host that stores the session object. And if that host goes down, which is much more likely for 1,000 hosts that host your server than for only one host, then this host has to be replaced and cannot know the session. So a session is lost if you do auto-replacement of hosts, for instance. The other thing is that, of course, HTTP, the protocol that is used by the client to speak to its server, is still stateless and connectionless particularly. That is, if the server doesn't hear from its client, then it doesn't know if there's just another request upcoming, or if the client has gone lost or lost interest or whatever and will come back ever again. So that is, there is no way actually, or no meaningful way to forget the server-side session state information. So, and what happens is the server-side session object is expired after a while, or it expires after a while. So if the server hasn't heard for, say, 5 minutes or something from the client, then it just throws away the session object. So, and now the point is that the more thing you do on the client side without talking to the server, that is, the more work you accumulate, and the more work will get lost or will become meaningful if the server-side session state object expires, the more likely it is that the server-side session object actually expires. So that happens all the time, for instance, in online banking also. If you have a very long form that you fill out, if it really takes a while because you have to look up something or so, if you finally submit the form, then the website tells you that your session was expired for security reasons, mostly. So that's then the big lie. So they even tell you that it is good for you, that their architecture is bad. So, and now the point is, for AJAX-based web applications, you can accumulate this interaction state that is so tedious to transfer back and forth along a long session or a long sequence of request-response pairs. You can accumulate all this interaction state on the client side, so you don't have to have the server-side session state object and still can, well, finally submit everything, but collect this user interaction state on the client side. And so that finally gives the possibility to correct this aberration that came up in the middle of the 90s and is now a real pain in the architecture of web applications. So if you like, yeah, anyway. So if you like, server-side session state is kind of the weapons of mass destruction of web application architecture. And okay. Is anybody here in the room who hasn't seen Google Maps? Please raise your hand. Oh. Mm-hmm. I'm never really sure if it's worth it, but I'm trying to give a brief demo then of Google Maps just to make the point what I'm talking about here, and also because it looks nice and it's always nice to look at. Though. Cool. Here you see Google Maps. So that's the application that I work on since a while. And here you can see basically the whole point, or the whole thing that I was talking about in the last few minutes. That's a map, right? And there are very many mapping websites. That map happens to be of New York, so that's the Upper West Side in New York. And there are very many mapping websites around. So MapQuest is 10 years old or even much more older than that. And usually they display a map embedded in an HTML page. And if you want to pan the map, that is to look to an area next to the area that you're looking at right now, then you usually have tiny arrows or something. And these arrows are links. And you click on these links. And for clicking on these links, you get back another HTML page that embeds another map, which happens to be the adjacent map view of the original map view. So you see that on MapQuest, and you see that on Stadtplandienst here in Germany, for instance. So, and now, and that's old-style HTML-based web application, what I said. So, and now, in this application, you can just take the map, take it with your mouse pointer and just drag it around. So, and you do that inside the page, for instance. So, and you can also zoom out and get a broader overview, and you can search for certain addresses. And you get a new map view, and you can, and that happens all in the same page. So there's no page reloaded or something. So, and you can request driving directions to another place in the city. This would be my way to work if I would drive by car in the morning, but of course I don't. There are these nice features to change the map view, and so the thing is that everything that happens with this map application, that all the user interaction is or happens to the same page. There's no page reload or something. So everything is loaded, or for instance, additional informations like the this line that represents the way from one point to another or something. Is requested from the server in the background and then incorporated in the page in the foreground when it arrives. So, and all this type of interaction, or all these interactions are just done on the client side. For instance, popping up this window with the blow-up map doesn't require any interaction with the server at all. That purely happens on the client side in the page. So, and if I request other information, for instance, Berlin should be sufficient, actually. No. Yes. Yeah. So if I look for another place, then of course this requires server interaction because the map has to know where this place, Berlin, happens to be. So, and again, if I just zoom in here, I wanted to see the conference center where we are at now, actually. All this doesn't require any interaction with the server, at least from the point of view of the page. Of course, other images are loaded, but that's not real logic. So, or to transfer these images is not real application logic in the sense of this interaction. So here we are. That's where we are now. Right? Okay. So much for this. Again, the point here is that we basically have user interaction logic, or a large part of the application logic of a web application running on the client side. So, back to where we were. Okay. Now, I have explained what AJAX is not about, namely all these things, or what is essential about AJAX, or what is not essential about AJAX, namely all these technologies that are mentioned in the name. So these are all superfluous, but obviously there is a technological base for what we are doing. So there are several ingredients without which these type of web application wouldn't be possible. So I'm going now to make a few comments about or describe these technological ingredients of AJAX applications. So now to introduce that, let me remind you that if you look at web technologies, or technologies that has been developed in connection with the World Wide Web, and compare that to, say, operating systems or programming languages, then I always have the impression that this is web technologies to real or other software technologies is a little bit like pop music compared to classical music or opera or something. So I mean, it is very similar, you know? I mean, it has a tune, it has a rhythm, and you have records, and you have venues and concerts and all that. However, it takes basically a microphone and someone to take this microphone and go on stage in order to make pop music, while it takes 15 years of education and then some talent too to make good classical music. So, and now if you look at web technologies, you have kind of the same impression. So, I mean, you have specifications, and you have implementations, and you have conformance, and all that. But if you poke a little bit and look at the details, it just doesn't look quite thought out, right? And it also, of course, was very quickly developed, right? While, for instance, C or something, or C++ has evolved over 20 years or so. Something like some of these technologies that I'm going to talk about has been cooked up by one single person in a hurry to the IPO of its company or something. So, and that of course shows a bit, and I'm going to show you So now, what is really in AJAX, or what are the essential parts of, or the essential technologies that we are going to use when we are building AJAX-based web applications? So first of it, there is, as I said, it is interactive web applications are much about graphics or visual display of something. So and the way to specify visual appearance in web applications is called CSS, that's cascading style sheets. So that's basically a way to describe the visual appearance and also sometimes interaction behavior, and also, of course, appearance in other media than visual media, but I'm not going to talk about that right here. So the visual appearance of all the things that you are concerned with in your web application. So basically you write the user interface of your web application as an HTML document, and in CSS you describe how it looks like. So whatever is in your user interface, you describe in CSS how it looks like. That is what shape it has, there it starts, you don't describe because there are no shapes except rectangles in CSS, but how big this single possible shape is, for instance, and where on screen it is positioned, and what color it has, and if you are using text, what font the text has, and so on. So, and all these things are described in CSS. So now, so much for the style sheet part. Basically, it describes the visual style of whatever is to be seen. Now, the worrying thing is, or the thing I want to comment about, is the cascading part. So the thing is that it was not the idea to have one such thing, but actually to have many such things, cascading or style sheets that describe the appearance of an application, and to make them somehow compete with each other. So there is supposed to be a cascade of those style sheets, and every style sheet comes from someone else. So one from the application or from the document author, one from the browser vendor, one from the user, and they all can have an opinion about how this should look like, what is going to be visible on screen. So this is one thing. And then the other thing about CSS is that there are very complex rules that allow you to apply your style description to elements on the page. It is not just that you say, okay, this element on the page has this color, but you can say, oh, all elements that are of a particular type or have a particular attribute, or whose parent has a particular type or particular attribute, can have particular properties. So in these rules, there are half a dozen rules that specify in which order all these different style specifications are eventually applied to your document. So what this amounts to is actually that a style sheet is the technological equivalent of a politician's election promise. So basically, it says something like, read my lips, this rectangle is going to be green. So, and then you can guess whatever it will really have at some point, or whatever color it will really have at some point. So that's a little bit awkward. And another thing I'm only mentioning this here is some things are really bizarre. So for instance, you can specify sizes, or usually you don't specify sizes because CSS was invented to format text, and text was supposed to just come in a flow. So, and basically, it is if you put text in boxes, then you make, per default, you make the boxes just as big as the text is, so that the text fits in, so, but not wider than the screen. But then you have an option to give those boxes that you fill your text in a size, and then it goes vice versa, and then the text becomes as wide as the boxes. And you can mix these two modes of layout in a page, but there's no clear rule which mode applies to which box on the page right now. So you can format inside out, so to speak, and outside in, and mix the two, but you don't know what you are doing at any given time, actually. That makes it also very tedious. And the last thing is just for illustrative purposes, there's one rule or one definition in the specification, which, by the way, you find on the World Wide Web Consortium website, that in case a box, I mean, there are many boxes, and usually the sizes of these boxes are somehow computed, so for instance, by the text content. But then there are boxes whose sizes cannot be computed. So for instance, or cannot be computed from the content of the document. For instance, images. Images are so-called replaced content, and those boxes take these external size specifications. And then there are boxes that also have external content, but this content doesn't specify a size. So for instance, iframes or so. And then the specification says that those boxes are 300 pixels wide. So except if that's too wide for the current screen. Then it just is smaller. So, and that's the kind of standard we are dealing with here. So, the next thing is the document object model. So, what we've seen so far is HTML with CSS, so that's basically how it looks like, but not what it does. So, and I explained that what it does, or what an application does on the client side, is specified in a programming language, to which we come in a while. And this programming language obviously has to talk to the page it runs in. So the programming interface of the programming language to the page it runs in is called the DOM, the document object model. So the document object model is basically an API for structured text. And to that API, I come in a while. But for here, or for now only so much, basically this document object model is something like the operating system API for classical applications. So it is a very fundamental thing, and you expect it to be very consistent and very well thought out and very stable and all that, which it actually turns out not to be. The next technology is JavaScript. So that's the programming language, and this programming language has been widely ridiculed for certain of its properties, particularly for its name, and also it has the bad reputation of being a silly language and not really respectable and all that, which it turns out it isn't. So it is actually a real nice language that has real nice properties and has nothing to do, which is one of its nice properties, with Java, actually. But anyway. And by the way, tomorrow I'm going to talk about a little bit more about this JavaScript programming language. So for now, just to mention, it is a real programming language in which you can write real nice programs. So the next big thing that goes into AJAX-based web applications is, of course, HTTP. And in particular, you have to have a programming interface to HTTP as well. So if you want to do from your JavaScript application, or from your JavaScript application logic, if you want to talk to the server, then you have to have an interface to it. So this interface is called, or nowadays is called XML HTTP request. So if you wonder about the capitalization of this name, why these are all capitals, while these are not capitals, then you hit it right on the spot. Actually, this is all also not really very well thought out. So basically what you need is an API to HTTP, and what you transfer over HTTP should not be so closely connected with the fact that you are transferring something at all. However, this object that is available in most modern browsers like Firefox and Safari and so on, basically rolls this task of making an HTTP session or making an HTTP request and transferring and decoding an XML formatted response into one object, although it doesn't have to do too much with each other. And I'm coming back to that in a while anyway. And the last ingredient is the transfer data format that you use to transfer those data that you that you use to marshal those data that you transfer over HTTP. So, and as I said, that is commonly regarded to necessarily be XML, although there are alternatives, and one of these alternatives are JavaScript object literals that are nowadays known as JavaScript object notation, so which is basically only JavaScript object literals. Anyway, so just a brief illustration of the DOM, the document object model. And by the way, or just one mention, if I talk about DOM or the DOM, then it is usually the document object model for HTTP as defined by the World Wide Web Consortium. So, and it has to somehow be distinguished from the concept of the DOM, that is to have an API for a document format. So, and many other document formats besides XML and HTML also have APIs, which make those APIs which make those APIs DOMs if this API happens to be object structured or object oriented. And other document formats which have document object models are, for instance, PDF and Shockwave, I'm sure, though I guess, but I'm not sure. And VRML, for instance, was another document format back then that also had a document object model effectively. Anyway, so this is a brief excerpt from one interface definition that is part of the document object model specification. So much only, the document object model of an HTML page looks like a tree. So that's basically a tree of nodes, and this tree has nodes, and every node in the tree is something on the page. So mostly HTML elements, but also text fragments and attributes of these elements, and comments and CData sections, and so everything in the page is a node in this tree. So, and that's basically what I said is the most fundamental interface against which we implement our application logic of our web applications. So, and as I said, this consists of nodes, and now this node has an interface. So it has attributes, and it consists of, or it contains some attributes. So now what I just want to point out is the naming of these, because that's really entertaining. So a node has a name, and the attribute that contains the name of the node is called node name. Okay, so and that's basically because the name was already taken at the time when this specification was made. So we couldn't call it name, so we had to call it node name. Then also a node has a value. Although actually not all nodes have values, but some of those nodes has values. Therefore, every node has an attribute for the value that is null eventually for those nodes who happen to don't have a value. So and this value is called node value. Okay. It also has a type, as I said. Nodes have different, or there are different types of nodes for different things, like elements, attributes, CData sections, comments. The document itself is also a node, and so on. So that's the node type. So then, as I said, the document object model is a tree data structure. That is, every node is contained or is the child of another node, which obviously is the parent of this node. So now, since a node has a node name and a node value and a node type, you would perhaps expect to have it a node parent, so that the parent of the node is the node parent. No, however, it is not. It is the parent node. Okay. And then, vice versa, a node has children, of course. That's why other nodes have parents. So that's the other way of the thing. And those children are called, like the parent node, child nodes. That is, the collection of the children is called child nodes. Okay. And now the last thing is, if a node happens to be an element, which not all nodes are, there are other nodes, but some of these nodes are element nodes, and those elements have attributes, or HTML elements have attributes, and attributes are also represented as nodes. So that is, a node has a collection that contains the nodes that represent its attributes. So, and since the children, or the collection of the children is called child nodes, you perhaps could expect the collection of the nodes that represents the attributes to be called attributes nodes. However, it isn't. So, and that's really funny to see in only the definition of 6 properties, 3 different conventions to come up with names. So, and contrast that, please, to something like the C++ STL, where you have a real watertight naming conventions and real well thought out concepts behind the names. So, and, yeah. And I think this is not purely aesthetical also. I mean, you can just say, okay, I'm just an over-aesthetical bitch, and what does it matter? But now the next thing, actually. So I explained, or some more substantial, and I explained that such a document structure of an HTML document is a tree data structure. So this tree data structure has elements like this. This is the tree data, or the document object model of this tiny HTML document. So these are the elements. This is the text, so that's also a node, that is a text node, and so on. So you can easily relate these two to each other. Now the thing is that this is text, right? And if you scan the text and construct this API from the text, then you have to do it one by one. So that is sequentially you read this text, and while you are reading this text, you are building this data structure. Now the problem is that this data structure has all these arrows that point upwards, right? So, and basically these are back references to container elements. The real problem now is that if you have read the document as a whole and constructed the whole data structure, you can create all these arrows, so to speak. However, while you are reading this text and have written it or have read it partially, say until after the div element, it is not really clear which of these arrows already exist and which don't. And the standard actually also doesn't make it clear. So the standard doesn't explain what happens or how does the DOM for a partially read document look like. So, and if you look at web applications as they are deployed nowadays, then you notice that the script that is embedded in the HTML page starts talking to its page before the page is completely loaded. And most of the time, it just gets away with it because the browser does something, and some of these properties exist. And if you happen not to talk to those properties that don't yet exist, you are fine. So there's a particularly nasty bug or well, actually it isn't a bug, but it is construed to be a bug because people don't realize this problem there. In Internet Explorer, that if you talk to an element in a partially read document, while a table in the page is only partially read, that is, you have basically, if you put script in a table that executes while it is being written, then Internet Explorer replaces the whole document with an error message that says, there was an error reading this document, or something like this. So something completely unintelligible, as you are used it from Microsoft and such. But the real thing is that it just stumbled upon this problem, that you basically can't tell how the DOM looks like if it is not yet complete. So that's a more profound problem with the whole standard than just the aesthetics of names, although I personally think that those are very important as well. So if you don't take anything else out of this talk, then please just never talk to the page while it is not yet read entirely. Only start running your script in the onload event handler. Okay. So much for this. Just a brief mention of JavaScript, or about a historical note about JavaScript. The thing JavaScript is most readily ridiculed for is the fact that it has this Java in its name. So because semantically, it really has nothing to do with Java at all, actually. It is as different as Java from Java as it could be, yet it is called JavaScript. So, and the thing that is worth remembering, though, is that JavaScript was invented at the time when Java was thought to be a client-side technology. So there was this concept of Java applets that you embed in a page that are written in Java that run as tiny applications inside the page, and particularly can also talk to the page that embeds it and talk to each other. And this orchestrations of different applets written in Java, embedded in an HTML page, talking to each other, was meant to be done in a scripting language. And this scripting language was JavaScript. So, and basically, JavaScript was invented to script Java applications, not as a script version of Java. So, and in that regard, it makes a lot more sense. Of course, this is nowadays completely forgotten because Java somehow didn't catch on as a client-side technology. So it is now a pure server-side technology, actually. Nobody writes applets anymore or Java applets anymore. So, and there's nothing Java left to be scripted on the client side. So instead, we script the DOM now. But still, so the language is not as ridiculously named as it appears. And in fact, it is a quite nice language. So tomorrow, I will go into a little bit more detail about these properties of the language. Only so much it has real nice features that are really different from Java. So for instance, it is object-oriented, yes, but it doesn't have classes. Instead, it has prototypes and uses delegation to implement inheritance. And it has a very rich syntax for literals. For instance, you have regular expression literals in the language, but you don't have in Java. So, and the way to execute a regular, or to write down and execute a regular expression in Java is particularly obnoxious. And in JavaScript, you just have literals as in Perl. You also have exceptions, and that, of course, and it has been called Lisp with a C syntax. So it is actually really nice. This Lisp with C syntax, particularly because you have this property of closure. So you can dynamically create functions, and these functions can retain the variable bindings of the local scope in which they were created, which is really, really nice. However, still some quirks remain, and those quirks are really ridiculous. So I only want to talk briefly about the semicolon insertion. And semicolon insertion is a thing that statements are separated by semicolons. However, the language was also invented for people who can't program. And for people who used to program in Visual Basic before, somehow. And therefore, there's a rule that you can also separate statements by new lines. So that is, if a statement ends at the line end, you can omit the semicolon that would separate it from the statement of the next line on the next line. However, statements also can continue on several lines. That is, the interpreter has to guess at the end of the line if the statement ends there, and there is just a semicolon omitted by a previous Visual Basic script programmer, or if the statement continues on the next line. And this is not always unambiguous. For instance, something like A, and on the next line plus B. So you can't know if this is actually A plus B, the statement, or if this is a statement A that consists only of the expression A, and if this is the unary plus operator, which happens to exist. Minus B would be more obvious. Anyway, and that's really a lot of much confusion and completely ridiculous and completely superfluous. It just really serves no purpose, but it's just in the language. So and you have some of these things. There was a question?
Is there some point in using semicolons? I have often seen JavaScript programmers using blank semicolon new line. Is there some point?
Yes, it's just better style. So it just avoids these pitfalls of semicolon insertion by the interpreter.
Blank before the semicolon?
No, that's just bad style. Semicolon is... yeah. Okay, so much for this. I have to hurry up a little bit because I'm running short of time. However, that's not bad because everything is still entertaining, I hope. A last thing again about JavaScript is JavaScript, as you notice, is embedded in HTML documents. So that is, you have an HTML document and you embed somehow JavaScript in it. So the way it is done is inside those so-called script elements. The thing is that the JavaScript is part of the document as content of an element. So and this is, interestingly, there's potential for conflict. So for instance, these angle brackets in HTML documents are reserved characters. So nothing can be an angle bracket unless it is a tag, or unless it delimits a tag. So in programming languages, there are these comparison operators, greater than and smaller, less than, so which also happens to happen in JavaScript. So this conflicts with, so if script contains these elements, then this conflicts with the surrounding HTML thing. The ampersand is also a reserved character in HTML, so that also cannot occur in the content of things. Then the only way that the browser recognizes the end of the script element is this end tag of the script element. So now if you happen to have script that mentions or that contains this end tag as a literal, for instance, if you have script that writes other script elements into the page, which is sometimes necessary, then you are screwed because the browser thinks that the script elements ends where it sees the end tag of the script elements, but the script actually continues. And the last thing is that a general convention in HTML is that if a client, so the World Wide Web, as you remember, was meant to be very robust and flexible and all that. And if a client that reads HTML doesn't recognize a particular element, then it just disregards the element and treats its content as text. So it basically omits the text or treats it as if there were no tags and just displays the content. So now in a browser that doesn't understand the script element, the script text would be displayed as text, which is obviously, well, not what it is intended to be. So and therefore, there are basically 3 different levels at which this embedded script can conflict with the surrounding document. And at all different levels, at the lexical, syntactic, and semantic level, so to speak, the choice that was made for the embedding of script in HTML was wrong. So because it created conflicts. So, and that's actually quite funny. So 3 out of possible 3 hits, basically. And as a workaround, you do really screwy things. So for instance, usually the content of a script element is embedded in these HTML comment elements. So and then there's a convention that the first line of a script element is actually not read as script because obviously the start comment sign is not valid JavaScript. So the convention is that the first line of the JavaScript is not read as JavaScript because there is this HTML comment line that prevents other browsers who don't understand the script element from displaying its content. And so on. Yeah. Okay, so much for that. I'm skipping over some illustrations of XML or of document transport. Yeah. Is that okay if I run a little bit over, like 5 minutes or so, because we have an hour time? Yeah, I know, but still, it's polite not to overrun its time. So, okay. The point I wanted to make about this XML versus JavaScript object notation. So that's how something like a location data structure looks like in XML. So you have this data element, and then you have a location element. This has 2 attributes, longitude and latitude, and yeah, those have values. These values happen to be here, actually. So those are our geographic coordinates. So, and the alternative is to just write a JavaScript literal data structure. So, and this is just a way to write literal objects in JavaScript. And you can see the similarities between the two. The thing is that this is actually valid JavaScript syntax. But if you receive something like this as a text fragment over in your HTTP response, then you can just call eval on it, and it evaluates to a JavaScript object that has these fields, as you see on the next slide. So after you've evaluated this, you have something that is called data, and it has a field location, and this has another field longitude. So you can access those values like this, like you access properties in a JavaScript object. However, you remember the way names are built or names are created in the document object model. The way to access an attribute in the document object model of this XML document that you've received looks like this, so which is much more tedious to write down, and it is also only a string. That is, if you really want to be sure that this is a number, then one way to do this in JavaScript is to subtract null, because JavaScript is very flexible in its type system, so it has types, but it is able to freely convert between types as necessary, at least between scalar types. And so if you have a string and subtract null from the string, and JavaScript goes ahead and looks if the content of the string looks somehow like a number, and then makes it into a number and subtracts null. So which makes it just the same number, except it is a number. Which is advantageous if you want to later add something to it, because the plus sign in JavaScript is overloaded, or the plus operator is overloaded to do string concatenation and addition. So if you try to add something that you think is a number, but it's actually a string that only contains the number, then you don't add to this number, but append to the string. So and therefore, it is sometimes necessary to really make sure that something that you believe is a number is actually a number. So and that's why you do things like that, which actually makes it really fun to program in JavaScript. So now we have seen that all these technologies are somewhat weird, right? And now I try to argue that it is still a good thing to use them all, actually. Although, I mean, you can judge for yourself. But two things I want to single out, or two aspects of this bunch of technologies and of the architecture that is used to create it. The one big thing is cross-browser compatibility. So, I mean, you've seen some code fragments here. And the thing about JavaScript is that not only the specification is somehow weird, but the implementations in the browsers is weirder still. So, I mean, whatever you think JavaScript does in a browser for you, you really have to verify that it really does it in all the browsers that you care about. So, and those browsers I care about are currently Internet Explorer, Firefox, Safari, and Opera. And there are really weird bugs in all those browsers, or different behaviors, let's say. So, and of course, there are also bugs, not only different interpretations of the standards, but bugs. And those bugs are always different in different browsers. So, and this is really, or sounds really terrible, but what it leads to is actually that it forces you to write really good libraries and to really have a separation of library code and application code. Whereas if you just program against one common platform, that is fine, then you tend to not to refactor your code into library and application code. And this way that you really have to deal with really weird idiosyncrasies of these browsers forces you to write good libraries. That's a really good point. I'm going to make a brief example, of course, in a while. The second thing is that that you transfer part of your application to the client, basically, and also write it in another programming language, namely JavaScript. And these two parts of your application, the server part and the client part, now only talk to this thin pipe of an HTTP session to each other. Really provides good segregation of application logic, or independent application logic and interaction logic, which is also a nice property, which you tend to neglect if your Java server pages and your servlets just run on the same server anyway, and you can just throw anything at your Java server pages, for instance, that actually is application logic or backend data structure or something. So this really forces you to maintain a good application. And also, on a personal note, if you have highly brilliant software engineers that are highly idiosyncratic, then this is also a good way to make them collaborate productively. So to just make the one work on the server side and the other work on the client side, and only let them talk through HTML or XML data structures, instead of having them reformat their Java code in reformatting wars or refactoring wars or so. That's also a very nice property of this kind of applications. So just a brief application, just a brief illustration of this writing good libraries thing, and then I'm done in 2 more slides. And thank you very much for your patience. So I said that a very central thing of these type of applications are events. So basically, you write your whole applications as a set of event handlers. And these events are registered with elements in your user interface, which happens to be, in the programming language, exposed as nodes. So, and now it happens that I said that there is not just one interface to register event handlers in the document object model. Instead, there are 3 of them. So, and these 3 of them are this add event listener, which is the official document object model by the World Wide Web Consortium. Internet Explorer has a different way. It says attach event. And there's an old style way of registering event handling functions, which is just assigning to a property that has the same name or similar name to the event. So all these examples register a function to be executed if you click on a certain element that is represented as this node object there. Interestingly, this is how it looks like to create dynamic functions in JavaScript. So you have just this function keyword, and you just can, at this point, if this expression is evaluated, it creates an object that is a function which can later be called. Anyway, so these 3 ways exist in order to register a function as an event handler on an element in different browsers. So, and what you obviously do is you never repeat this more than once. What you do instead is you create a function that does this event handling registration for you, and is sensitive to the different interfaces that exist in the browser. So and here you have it. If you have an add event listener function, then you use the add event listener function or method. If you have this add event method, then you use the attach event method, and else you just set this attribute. So far, so good. And now notice this first block or the first line. So it happens that Safari, the web browser by Apple, generally supports this add event listener interface to register event handlers, except for this event called double click. So the double click event, you have to register using this on double click attribute. And this is something you figure out once and put it in your library, and then it's done. So, and if these last three are not yet a good reason to have this library function, then the first one is so. And so to have to deal with all this browser idiosyncratic weirdness really forces you to just write good abstractions and put them in libraries. So and
but it's a hard problem when the next version is coming out.
oh yes, of course, yeah.
You have to look through all your library.
Yeah, that's true. Yeah, and that's actually a good occasion to go through your library, clean up the code, refactor it again. So, yeah, so you see, I'm arguing that this weirdness and crap is actually good for you and your software. So, yet, some things in practice are still challenging, however, so in AJAX-based web applications. So I'm just going to mention there. So one big thing is deployment. So big applications consist of very many files, and you can't afford to load all different JavaScript files in an HTML page. So what you have to do in order to deploy your application, you have to somehow roll all these files into one, for instance, and on the way just remove comments and rename identifiers to shorter names in order to save bandwidth, and so on. So, and you have to come up with a versioning scheme that, or with a modularization scheme that allows you to exploit browser caching most effectively. So you want to somehow modularize your library into several modules, such that if you make an update to your library in your release schedule and release that, then the browser doesn't have to refetch all the compiled code, but can still exploit caching for the compiled JavaScript code. And for all these kinds of things, there are only best practices around now, but not yet tools or something. So just JavaScript deployment is still handwork, and JavaScript compilation, obfuscation, so just preparation for deployment is just handwork, and you write tools manually still. So that's a big thing for development. Another thing is bookmarking and history of these applications. The thing is, of course, if you have a page and you interact with the page and the page accumulates state, then this state is not represented in the URL of this page, of course. So, and also if you do something and the page doesn't reload, then the previous state of the page is not recorded in the browser history. So you can't just go back using the browser history. Yet, bookmarking and browser history are very important interaction patterns with web applications. So you have to go to extra length in order to implement this. And for instance, in Google Maps, we do both. One is very explicitly, so you have on every page, or on the Google Maps page, you have a link to this page. And this link to this page always contains a URL that represents the current state of the page, although the URL itself doesn't change if you do something like do a new search or pan the map or whatever. So, and also whenever you do a search, a new entry is created in the history through, well, one of the common tricks that are applied to it. So, and that is one area that needs to be developed further. So, and new browsers or modern browsers also have more support for explicit interaction of web applications with both the bookmark set and the history. And the last thing is frameworks. So there are now AJAX frameworks popping up. So, and the big thing, or the important thing, is actually to resist the temptation to use a framework or to build a framework even, because there already is one. That framework is called browser. So, and if you think of it, the browser does for web applications exactly what normally a framework does for graphical user interface-based applications. So it basically initializes the main loop, allows you to register event handlers, generates the events, schedules the event handlers for execution, provides tools in which, or vocabulary in which to implement or describe the actions that the event handler execute, and so on. So basically, the browser is already the framework for your application, so because it just does everything of that. And it is quite tedious to deal with yet another layer around all that. So, and it's of course important to have tools or lightweight libraries, like the event handler library function that I demonstrated, but it is mostly a step in the wrong direction to develop a framework for AJAX applications. So, and yet they are popping up, and that is going to create some hassle, probably.
Are there some ready-to-use libraries with the common stuff?
Oh yes, Google for AJAX. Mm. Yeah. Yeah, okay. So,
Are there good and better ones, good and worse ones?
I don't know. So I write most of the stuff I need myself, and yeah. Of course, I mean, you don't want to do that infinitely. So for instance, more complex interaction widgets, you don't want to write yourself again. So like pull-down menus and tree widgets and all that stuff. But still, a thing to look at is, if you look at such a widget implementation, and you can use a widget standalone. That is, you can use a tree widget, for instance. Just put it in your page and have a tree widget on your page, and don't have to initialize your whole page in some framework or something, then that's a good sign. So, and that's what you are looking for. So you look for very well separated collections of things, widgets, functions, whatever, instead of a homogeneous monolithic framework. Okay, to conclude with, I just want to mention some of the other buzzwords that are around. Mobile code was very fashionable in the 90s or so, and I think that JavaScript or these web applications has come as close to mobile code as we could have hoped for 10 years ago or so. Another thing is application state migration. So I recently heard a talk of Jim Geddes, who is the inventor of, or one of the co-inventors of the X Windows system. And he complained, or he said that one of the biggest design mistake or architecture mistakes of the X11 system is that there's on every X server only one user. So you have this one mouse, one keyboard, one display thing. And application state migration doesn't work at all. So if you are at the server, then you are bound to the server, and you can't just take your application with you moving to another display or something. So neither can two users in one display, nor can one user use two displays transparently. So in this application state migration, if you think of it flexibly enough, then this URL-based representation of interaction state does exactly that. So you basically can take your application state with you, mail it to somebody else in an email, put it in a bookmark, or put it in a file and retrieve it later, and so on. And that's also as close as it gets currently to taking the interaction state of an interactive application with you to another display. So it's very rudimentary, but it is very interesting to notice that this actually does something that other and much older technologies fail to do. Software as a service also buzzword that is recently around. And a very interesting thing is client-side application integration. And another thing I'm going to talk about tomorrow is the fact that the Google Maps service has an API that basically allows you to embed a map in any HTML page. So that is, whenever you talk in a page about a place, you can just put a map of this place in this page. And it still uses the Google Map, but in a page that comes from entirely somewhere else. And the interesting thing is to think this idea further, and to think that there are services published in the web that you can just put together in web pages, and on the client side, not on the server side. That's the big thing here. You can use these services just by referencing them in the text that is sent to the client side. And the integration and this orchestration of the collaboration, again, happens only on the client side. And that's a very nice perspective if you manage to look at it under this regard. Yeah, so much for this. Thank you very much for your patience.